Let's do this quant problem together.
We are given the fact that there is a random sample from uniform 0, 1. U is the minimum of the sample and V is the maximum of the sample. And you have to find the probability U plus V is greater than 1. The first step is to recognize the underlying concept. You can recognize that U and V are minimum and maximum order statistics respectively, and the concept is order statistics. And the goal is to find probability U plus V is greater than 1, as already mentioned. Now, if you do it in an organic way, you have to first step is to find this probability. The first step is to find the joint density distribution, and you realize that it will come out to be this, and then find this conditional probability distribution, and then you do a bunch of integrations. And interestingly, I suggest you do this, you will find out the answer to be half. And that will ring a bell in your mind that is there a solution that uses symmetry? So let's understand that. So what we'll understand, we'll look into the symmetry that exists in the problem itself. So we are given uniform 0, 1. So observe this, if x is a random variable following uniform 0, 1, 1 minus x is also a random variable following uniform 0, 1. We will define a set of new variables, yi, which is 1 minus xi. Observe that if xi, since xi's are uniform 0, 1, yi's are also uniform 0, 1, and all are iids together, the sample. Now, let's use this fundamental minimax property. Observe that minimum of 1 minus x, 1 minus y is same as 1 minus max of x, y. You can solve this example out really quickly. And the same thing holds for max. Now, let's denote u dash as the minimum of yi's. Remember, yi is 1 minus xi's, remember that. And it will turn out that that is equivalent to minimum of 1 minus xi's, and that is, using this property, it will be 1 minus max of xi's, which is nothing but 1 minus v. So u dash is 1 minus v. So also observe that u is equal to the minimum of all xi's, right? And u dash is minimum of all yi's, right? And since xi and yi's are all identically distributed, hence u and u dash also identically distributed, right? Beautiful, right? So now let's go to the probability section. You have to find the probability u plus v is greater than 1, and that is equivalent to saying probability u is greater than 1 minus v. And we have seen that 1 minus v is nothing but u dash, right? So if we are asked to find probability u and u dash, probability u greater than u dash. Now we will use this banger property that u and u dash are identically distributed and continuous random variable. Now observe that the sample space can distribute into these three halves, u greater than u dash greater than u, and u equal to u dash. And observe that since u and u dash are continuous random variables, probability u equal to u dash is always 0. Okay, and we are left with the fact that it is distributed with positive probability, u greater than u dash and u dash greater than u, and both of them are equal by symmetry. This is a symmetric property. So therefore, each of these probabilities are equal. It is half. So the answer is half.